Maybe you've not thought about this before. There is a good side, a bad side, and an ugly side to every finite element solver. And in this video, I will be reviewing the good, the bad, and the ugly side of ABAQUS. I believe you'll be blown away at the end of this video. So watch to the end and let's sit back and relax as we get started with this video. So the first thing is, what is ABAQUS? ABAQUS is basically a finite element solver that is marketed by this company called Similia. It's one of the most popular finite element solvers that is out there, and a lot of times students use them to do really very interesting computational modeling approaches. If you are regular in this channel, you would have seen that most of my videos are made essentially using ABAQUS. The idea here is not to say some things bad about ABAQUS, but just to kind of point out what are the strong points and the weaknesses of this solver so that you'll be aware. So in terms of the good part of ABAQUS, there's so many good things associated with this software, and the first of them is that it's got an excellent integrated development environment, and this is what ABAQUS itself calls the ABAQUS CA, which is basically a acronym for complete ABAQUS environment. And it's really a powerful environment because you can do the post-processing, the pre-processing, and even the simulation of the solver. They are all done within that same window. So this makes it really very popular in comparison with some other solvers where you may have to load a module to do the pre-processing and then a second module for the analysis, and then the post-processing will also be done in a different module. But all that is integrated with ABAQUS, and this makes it excellent. The second thing that is a good feature of ABAQUS is the fact that it has excellent documentation. In fact, when you look at all finite element solvers, ABAQUS is the one that has the most comprehensive documentation. The documentation tells you about the analysis procedure, the theory behind what you're trying to do, example files that you can use to run your simulation, a scripting module, a dedicated module for helping you with scripting and commanding what ABAQUS does. There's also a documentation just simply about verification of your model. So it gives you models, example models for verifying a setup. So it's very, very good documentation, and this makes it excellent in the community. The third thing that makes ABAQUS stand out quite well is the fact that it is the first finite element solver that actually integrated a user-defined material model, which is commonly called a UMAT or a VMAT, within the finite element modeling community. In the past, what people tend to do was you just work with the material models that are given to you. However, ABAQUS was the first company that created a user-defined material model, which means that you can then change a material model, write your own user-specific material model, and then implement that within ABAQUS and then run simulation. And that gave companies a lot of competitive advantage. It also meant that researchers working in universities could actually come up with innovative material models, implement it in ABAQUS, get excellent prediction, and then show off essentially what they are doing with their research. This is possible within ABAQUS, and that's one other good feature associated with this software. The other thing that makes ABAQUS excellent too, another good feature is that it has this feature for integrating the ABAQUS environment with a professional computer-aided development environment, something like SolidWorks or CATIA. So you can create your model in that environment and interface it with ABAQUS. And so this is an excellent feature associated with ABAQUS. That means if you're working within a product development company and you can use the model that you've created, find a way to interface it with ABAQUS, and then you can make changes within that CAD environment, and that will automatically reflect in what you're trying to do within ABAQUS. This is a fantastic feature, especially for people working in product development, and another good feature of ABAQUS. Also, in terms of the interface, the other feature that also stands out in terms of a good feature with ABAQUS is the fact that it is a solver that can actually also integrate nicely with something like a MATLAB, so you can control ABAQUS directly from inside of MATLAB. In fact, if you're interested in this, I made this video that will tell you a little bit more about that. Also, Python programming languages become really a powerful, popular programming languages. So if you know how to work in Python, you just need to understand the object libraries that work with ABAQUS, and easily you can control what happens in ABAQUS within Python. It can improve the behavior of your model by coding it up in Python. And even for most users that are conversant with Microsoft Excel, you can also operate, control a little bit of what happens in ABAQUS within Excel, also take results from ABAQUS directly into Excel. So this is another feature that makes the software really useful. The last point in terms of the good feature of ABAQUS is that it's one of those software that is really very useful for researchers. What you tend to find is that in the industry, a lot of industry users tend to work a lot with ANSYS. But ABAQUS really, because of the way it's designed, is very, very good for people that are working in academic research. And the essence for this is because it allows you to build your model from first principles up to whatever level that you're wanting that to be. But the main reason here is that ABAQUS is one software that allows for design freedom, for you to be able to create whatever model you want as freely as possible. So there's no presumption about materials, no presumption about unit system, no presumption about, interfaces. Everything you're trying to do, you control comprehensively. And for people that work in academic research, this is really essential for them because they want to control everything they're trying to do. The very good thing about ABAQUS has to say is that it has a really very stable finite element solver. You hardly have ABAQUS, crashing on you. I've used ABAQUS extensively a lot of time, and it hardly crashes on me because the solver is excellent, it's very stable, it's highly verified, and a lot of industry organizations are using it because of the reliability and the predictive fidelity of predictions that come from ABAQUS. And this is something that we're worth considering. If this is the kind of content that you like, please do subscribe to this channel. So when content like this are made, you'll be the first to see it. So let's move on to the next parts of this video, which is around what I call the bad features of ABAQUS. And the idea of describing this thing as bad doesn't mean, they are extremely bad. The essence really is things that are worth considering, things that I would have liked to see within the solver that are not essentially there, and things that could serve a little bit of a limitation within the software, which means that sometimes users will struggle to use them. And so that's what I'm calling the bad feature. They just don't fall within the good feature of ABAQUS. And the first of them is really around the material library. Most finite element solvers will have an inbuilt material library, something like ANSYS. So if you want to then model a piece of steel material, you just go to the library, drag your steel material in, and then you start. Within that steel material library, it has all the properties of the steel, the Young's modulus, the stiffnesses, everything will also be specified within that library. However, in ABAQUS, there is nothing like that. What you have is the material models. So you've got elastoplasticity, you've got crystal plasticity, you've got damage, Johnson-Cook model, all that, and all the parameters are specified. It's now left for the user to find for different materials you're studying. So if you're studying steel, you need to find the properties that fit into that. And a lot of times when my students start using ABAQUS, they really struggle with that because if you're working with SolidWorks or you're working with ANSYS, you don't really have this kind of problem. But with ABAQUS, you really have this problem. And so much as I like this feature because it helps with research and it means that you can do whatever you like, you can create your model the way you want. However, for people that are not used to using this way of thinking, it means that it can be difficult. So you'll be wondering, what properties I need to take in modeling my steel? So you need to go and consult, material handbooks to generate all these properties, and how you can interpret them and put them into ABAQUS can be a problem. And so this is what I could say a bad feature of ABAQUS. I wouldn't want it to be removed, however, and ABAQUS has stuck to their guns when it comes to this. However, I think I will class it under the bad feature of ABAQUS. Tell me in the comment section of this video if you think that, this is really as bad as I'm making it, or, you do not mind it in terms of how you use this software. The second thing that could be considered as a bad feature of ABAQUS is the fact that ABAQUS doesn't really have a standard way of dealing with periodic boundary condition. Rather, what it will have is a constraint equation which you can then use and code up for yourself how a periodic boundary condition would work. I understand that in COMSOL, there is an inbuilt periodic boundary condition consideration, and then sometimes for a certain material module in ANSYS, periodic boundary condition also can be handled automatically. But there is no feature like that within ABAQUS, and that in itself can be maybe a challenging thing because most times users would have to then find a plugin to help them do periodic boundary condition. If you are interested in how periodic boundary condition can be handled within ABAQUS, I've made videos to help you with that. So particularly look at this video that tells you about how to do it manually, and also this other video that tells you how to do it automatically. The third thing that could be considered as a bad feature of ABAQUS, and this essentially is because of these issues that I've referred to earlier on around material choice, is that it can be quite difficult for inexperienced users to know their way around, because a lot of things are not so intuitive in terms of how you use them. So at least this is what I see with my own students. They tend to struggle to get started with ABAQUS. But once you get started with ABAQUS and start playing with it, a lot of times students report back to me that it's actually an excellent software and they like the way it works and the flow of it. But picking up the first time can be a little bit challenging. And I think the worst of the features here that I consider the bad part of it is that in terms of market penetration, ANSYS has a very high market penetration compared to ABAQUS. ABAQUS is really struggling to penetrate in the market. And this is because ANSYS was right ahead of ABAQUS. It started the race earlier, and so it's got a lot of people using it already compared to ABAQUS. And so the market penetration can be a problem, especially if you're an organization looking to which of these FE solvers that you want to use. You may find out that ABAQUS are not penetrated the market. That can be a feature that kind of would dissuade you from using it. And that I will class under a bad feature, a bad aspect to ABAQUS. So the third category for understanding what's happening with ABAQUS is what I describe as an ugly feature. In fact, this really is detestable. This is something I would like ABAQUS to change. And then I need viewers on this channel to be aware of this. And the first of them is that it is quite an expensive software to use, especially when you compare with other competing software like ANSYS, LSDyna, or COMSOL. Every time I try to get a quotation from the distributors of ABAQUS, the company Similia, I always find that the quotation is always a little bit more expensive in comparison to some of the other software. And that can become a problem. Admittedly, it's an excellent software. It has a lot of features and there's a lot more that they offer you, maybe in comparison with other solvers. However, the cost implication is something that we need to really look into, especially for students and researchers and organizations, universities that are working in this environment, maybe not for profit. It would really make a lot of sense if the cost can be a lot cheaper. The second point is also allied to this fact that it's very expensive, and this is the fact that it's quite limited in terms of the features that are available for students to use. ABAQUS has a student license version, but it's very, very limited. It only allows you up to 1,000 notes discretization. And most models you can't do much with 1,000 notes. And so it will make sense for ABAQUS to try and increase that feature. Maybe allow the students up to 10,000 notes so that they can do some kind of learning, understanding the software. But the company has fixed the nodal discretization for the student license to be up to 1,000 notes. The other thing with this student version is that it doesn't allow the student to be able to use the user-defined material model aspect of ABAQUS, because you don't have that possibility within the student license, so students are not allowed. I'm thinking that most of the students are researchers working in universities and research institutes. They want to be able to at least create their material models and run them. But the version of the ABAQUS student license doesn't allow for that. And then also, even when they create a model, let's say in SolidWorks, there's no possibility of importing and playing with that model within the student version. So it's super limited, and that in itself is what I consider an ugly feature associated with ABAQUS, and people need to be aware of this. The third thing that could be considered as an ugly feature of ABAQUS is that there is no multiphysics associated with it. You know, with something like COMSOL, you could do a lot of multiphysics simulation. You could do structural analysis, fluid dynamics analysis and thermal analysis all within one nodal. However, if you want to do this, then you have to navigate complex, different solvers and try and find a way of incorporating the result. So this is something ABAQUS is still trying to improve on and incorporate a bit of multiphysics. However, there is a challenge in that. And I would imagine in future, with more solvers becoming available, being able to do multiphysics simulation will be essential. So this is something ABAQUS will do. But for now, this is what I consider an ugly feature of ABAQUS. So having reviewed all three, good, bad, and ugly side, I open the question back onto you. Do you agree with some of the things I've said about ABAQUS? Is there anything else that I'm missing about ABAQUS that you think is essential and worth considering? And let me know in the comment section of this video. I mentioned earlier on about the possibility of doing periodic boundary condition within ABAQUS, and I've shown how to do this. So these are two videos that can help you to do it both automatically and manually. So go ahead and watch it, and I'll see you in the next video. Thank you.